Hello dear children, today we will see numbers having rotational symmetry. First we will take 0 and this is the start position. When I move it slowly like this into half a turn, it will come upside down and still it is looking 0 only. So we can say that 0 has rotational symmetry. And how many times it is looking the same? So it is looking the same 2 times. One at the original position and one when it is coming to 180 degrees. So the order of rotation of 0 is 2. Okay. Now let us try out with some other numbers. Now let's take 1. So even 1 also, when I rotate it like this is half a turn and still it is looking 1 only. So this is order of rotation 1. Once it is looking the same, now twice. In its original position also it is looking the same. So this has order of rotation of 2. Next we'll try with 2. So do you think 2 will look the same after half a turn? See, it is not looking the same. So it is looking the same only in its original position. That means it has no rotational symmetry. And some of you were confused with 3. So let us see what will happen if I bring 3 here. Will it look like 3? No, it will look like the reflected 3 that we see in the mirror. So this is not the 3. We can't say it is looking the same. So it has no rotational symmetry. So let's try out with 4. So we can easily say that even 4 also will not look the same. So it has no rotational symmetry. And what about 5? Even 5 also will not look the same. So it has no rotational symmetry. 6. Even some of you were thinking that 6 will look the same. So what will happen if I bring 6 at this position? It is looking like 9. So it is changing. It is not looking the same. It has no rotational symmetry. After giving half a turn, these digits are not showing rotational symmetry. Even 7 also is not looking the same after giving half a turn. Now let us see with 8. So when I bring down 8, it will look like 8 only. So we can say that it has rotational symmetry and its order of rotation is 2. 1 at its original position it's looking the same and 1 when I bring it down here. That means after half a turn. Okay. Now let's try out this one, 9. So what will happen when I bring it down? It will look like 6. So that means it is not having rotational symmetry because it is completely changing. So now you know which are the digits that have rotational symmetry. 0, 1 and 8. Okay. Now children, see here is a full circle and you know that a full circle has 360 degrees. If we move like this, if we complete this, this will be one full rotation. And half of that is, see here, if we divide circle into 2 equal parts, half of that will be 180 degrees. Here the circle is divided into 4 equal parts. Okay. So 360 degrees we have to divide by 4. And one part will be equal to 90 degrees. The other part 90 degree. The third part also 90 degree and the fourth part also 90 degree. So 90 plus 90, 180 plus 90, 270 plus 90, 360. Okay, this is how we call. 1/4 turn means 90 degrees. Half a turn means 180 degrees. 3/4 turn means 270 degrees. Full rotation means 360 degrees. Okay. Now I have a square here and I have marked the outline of the square to check how many times it will look the same in one full rotation. If I move it like this, it has to fix in that position. Let us see, and let us see what is the order of its rotation. Now I have fixed the square here. If I move it slowly, so this is 1/4 turn. Now see, it is exactly fitting into this square after 1/4 turn and it is looking the same. Now if I move it once again, this is called as half a turn. Okay. Now also it is looking the same. If I rotate it slowly, this is 3/4 turn and still it is looking the same. And if I bring back to its original position, still it is fitting into the outline and it is looking the same. That means the order of rotation of a square is 4. 4 times it is looking the same. Here I have a rectangle like this. See, this is a rectangle. I have made the outline of the rectangle. Let us see when and how it will look the same. Now children, this is a rectangle. It's a sleeping rectangle as told by you. See, I have put a dot here to make you understand that this is the start position. So if I rotate it like this is 1/4 turn. So after 1/4 turn, it is not looking the same. When I bring it here, now the dot has moved to the opposite direction. That means it is half a turn, and at half a turn it is looking the same, isn't it? It's fitting into the outline. If I rotate it once again, this is the 3/4 turn. Here also it is not looking the same, and when I bring back to its original position, it's looking the same. That means this rectangle is looking the same, one at 180 degree, next at 360 degree. So the order of rotation is 2. Here I have another rectangle and I have made an outline here in standing position. Now I will fix it and rotate it to see when and how it will look same, and I will also mark a point here to make you understand the starting position. Okay. Now I will rotate it. See, this is 1/4 turn. That means 90 degree. So at 90 degree, it is not looking the same. When I bring it to half a turn, so the dot was here. Now you can see the dot here. That means this part has come down here and it is fitting into the outline. It is looking the same. Now if I still rotate it, it is 3/4 turn. Here also it is not matching to the outline. Now if I bring it back, again it is looking the same. That means the order of rotation of a rectangle is 2. Once at 180 degree it will look the same, and next at 360 degree it will look the same. Children, I have a circle here and I have made the outline of the circle. Let us see how many times it will look the same in one full rotation. Children, I have marked a point here to make you understand that this is the starting position. Now if I rotate it, whatever the degree is, it is looking the same, isn't it? See, even after half a turn it is looking the same, and at every angle it is looking the same. Now we have brought it back to the original position. That means a circle has infinite number of rotation. That means we cannot count. Every time we rotate it, it will look the same. Children, now I have taken a triangle and made an outline of the triangle. It's an equilateral triangle. That means a triangle in which all the sides are equal and all the angles are equal. Let us see if this shows order of rotation. So if I give it 1/4 turn, it will look like this. It is not matching with the original outline. If I give it half a turn, it will look like this. So here also it is not looking the same. At 3/4 turn also it is not matching. It is matching only in its original position. So this is not showing rotational symmetry after giving 1/4 turn, half a turn or 3/4 turn. Now here is a full circle. I have divided into 3 equal parts. Here each part will be equal to 120 degrees. That means 360 degrees divided by 3 gives us 120 degrees. So this is one part, second part, third part, and each part is called as 1/3. Now I have made an outline of this triangle here. Let us see it will look the same or not after giving it 1/3 turn. Here I have marked the dot here. Children, this is the starting position. If I give this triangle 1/3 turn, see, it is exactly fitting into the outline and it is looking the same. Now if I give it one more 1/3 turn, still it is looking the same. And when it comes back to its original position, it is looking the same. That means a triangle, an equilateral triangle shows rotational symmetry at 1/3 turn. Okay, 120 degree, 240 degree, 360 degree. Children, now let us see some of the designs that look the same after giving them half a turn. See, here we have red part and the yellow part. If I rotate it like this is 1/4 rotation and it is not looking the same. Now the color has changed. When I bring it like this is the same as the original. The red was on the top, now red on the bottom. So it is looking the same at 180 degree. Here also it is not looking same after 3/4 turn, and here it is looking the same. It is looking same twice. Once at half a rotation and one at the original position. And the order of rotation of this shape is 2. Now let us see one more example. In this figure you can see 3 blades here on the top, 3 at the bottom. If I give it 1/4 turn, it will change. So it is not looking same. But after giving it half a turn, this is upside down and it is looking the same at 180 degree. Now it is not looking same at 270 degree. But when I bring it back to its original position, it is looking the same. So even this figure has order of rotation 2. Now see here in this beautiful figure, if I rotate it 1/4 turn, it is not looking the same. But after giving it half a turn, it is looking the same. And if I give it 3/4 turn, it is not looking same. But again at the original position, it is looking the same. So this is a figure that looks the same after giving it half a turn. Now let us look at this figure. Here the yellow part is at the top as well as at the bottom. If I give it 1/4 turn, it is not looking the same. But when I give it half a turn, it's looking the same. And again 3/4 turn, it is not looking the same. But when I move it back to its original position, it is looking the same. Twice it is looking the same. So its order of rotation is 2. Children, I have a plus sign here. Now let us see what happens if I give it 1/4 turn. It is looking the same by giving it 1/4 turn. If I give it half a turn, still it is looking the same. If I give it 3/4 turn, still it is looking the same. And if I complete one full rotation, it is looking the same. That means this figure shows order of rotation as 4. So it is looking the same at 1/4 turn, half turn, 3/4 turn as well as full rotation. 90 degree, 180 degree, 270 degree as well as at 360 degree. So in this figure, let us see what happens if I give it 1/4 turn. So it is still looking the same. After giving it half a turn also, it is looking the same. When I give it 3/4 turn, still it is looking the same. And when I complete one full rotation, it is looking the same. So we can say that the order of rotation of this figure is 4. 4 times it is looking the same. Here I have a X. If I bring this blade to this position, it will look same. Now this will go to this place. Still it will look same after giving half a turn. If I give 3/4 turn, still it will look same. And if I complete one full rotation also, it will look same. That means the order of rotation of this figure is 4. Children, I have some figures now. This is a star. Let us see if it looks same after giving it 1/4 turn or half a turn. No, it is not looking same. Even after giving half a turn, though the shape is same, it is a star, but there is a change in the color. So it is not looking same. After giving it 3/4 turn also, it is not looking same. And when it comes back to original position, it is looking same. That means this figure looks same only in its original position and it has no rotational symmetry. Now I have this shape. If I rotate it, this is 1/4 turn. No, it is not looking same. After giving half a turn also, it is not looking same. Even 3/4, it is not looking same. So it is looking same only in its original position. That means even this figure is not showing rotational symmetry. Here I have a beautiful figure. If I rotate it, so at 1/4 turn, it is not looking same. Even after giving half a turn, it is not looking same. 3/4 also, it is not looking same. Only in its original position, it is looking same. That means this figure shows no rotational symmetry. Children, I have a fan shape here with 3 blades. 2 blades are brown and 1 is pink. Now what will happen if I give it 1/3 turn? Will it look the same? Let us see. See, there is a change in the color. Now the brown blade has come here and the pink has gone up. Even after giving one more 1/3 turn also, there is a change in the color. So it will not look the same after giving it 1/3 turn. Children, I had asked you to make a windmill like this, having 4 blades. Now if I rotate it, if I give it 1/4 turn, what will happen? This blade is coming here and this is moving here and this is moving here, and still it is looking the same. After giving it half a turn also, it's looking the same. And if I give it 3/4 turn, it is looking the same. And after completing one full rotation also, it is looking the same. That means this shows order of rotation 4 and this has rotational symmetry. Now what will happen if I change the color of the blades to yellow to brown? Think about it. Will it look the same after giving it half a turn? You have to think and explore. Okay. Children, I hope enjoyed all these activities, and I expect you to do similar things at home. Collect more symbols and you try out such activities at home and see which of the figures have rotational symmetries, and also try to find their order of rotation.